How's it going, guys? Today in this video, we're going to be going over module 11.1, day 2. We're still going to be talking about inverses, but today in this video, we're going to be talking about inverses of cubic functions. So the very first thing we should pay attention to is that a cubic function is a one-to-one function, or in other words, every x value is going to go to a different y value. Unlike quadratics, where quadratic is a many-to-one function, where you'll have multiple x values giving you the same y value. A cubic function, every single x value is going to give you a different y value. So because of that, we do not need to restrict its domain to find its inverse. All right. We only need restrictions when a function is many to one, but if it's a one-to-one function, you do not need to restrict the domain. And the inverse of f of x equals x cubed, or the inverse of a cubic function, is going to look like this. F inverse of x equals the cube root of x. So the inverse of a cubic function is going to be called a cube root function. The parent cube root function is just going to be the simplest cube root function we can write, which is just the cube root of x. So let's go on to the next page, or the next slide. It should be on the same page for you guys. But anyway, we're going to go over an example on number 1. So finding the inverse of cubic functions will be the exact same thing as finding the inverse of a quadratic. All right. So very first thing I'm going to do is I'm actually going to change this function, and I'm going to write it as a fraction rather than a decimal. It doesn't really matter, but I think when solving for the inverse, having it as a fraction makes it a lot easier than having it as a decimal. So I'm going to change 0.5 to 1/2, and now we're going to find the inverse. So here, it says replace f of x with y. So we have y equals 1/2 x cubed. Then we're going to solve for x, which is going to involve cube roots. So if we solve for x, we get that, we can multiply by 2 on both sides. So we get 2y equals x cubed. And then we can take the cube root of both sides to get that x is going to equal the cube root of 2y. And then we switch x and y, so we get that, or we get y equals the cube root of 2x. So if you watch the other video, or if you're a student of mine, I know how I did it is I switched x and y from the beginning and then solved for y, rather than solving for x and then switching x and y. It's the same exact thing. You can do it either way, and you'll get the same thing regardless. I personally prefer switching x and y from the beginning, so I like to switch these 2 steps. Step 2 and step 3, I like to switch it. I like to switch x and y, and then solve for y. Either way, it doesn't really matter. You're going to get the same inverse. All right? So anyway, the inverse function that we found is f inverse of x is going to be the cube root of 2x. That's what we think the inverse is. So what we're going to do now is we're going to confirm that the inverse is actually our inverse by using composition. So composition, that's going to be f of f inverse of x all equals x. That's half of it. And the other half will be the inverse of f of x. Let's actually write that as a lowercase f. F of x equals x. So we need to make sure both of these equations hold true, and if they do, then it's the inverse that we found is indeed the inverse of the function. So for the first one, what we're going to do is we're going to write f of x, which we said was 1/2 x cubed. We're going to write this as a function in terms of f inverse of x. So actually rewrite this really quickly so you can make it a little more clear. So f of x, that's going to be 1/2 x cubed. And what we want now is f of f inverse of x, which we're just going to replace the red part here, or the x, with our function. We want the function of f in terms of x in the first one, But in the second equation I have written down, we want f in terms of the inverse function. So instead of x, we're writing the inverse function. So 1/2 inverse function we said was the cube root of 2x. And we have that cubed in the top, so all of that cubed. I'm just not writing anything all too nice. You just make it look a little nicer. All right, so that's what we have, and now we're going to solve this out. So cube roots and cubic functions, or cubic exponents, they cancel each other out the same way squares and square roots do. So that means these cancel out, and we're left with 1/2 times 2x. 1/2 times 2x is just going to give us 1x, or just x. That's exactly what we wanted. So this half of the composition is true, but we need to make sure both halves are true to make sure to be able to see that the inverse that we found is our inverse. All right, so let's go ahead and solve the second part. In this part, we want the inverse function. We want to write this in terms of f of x. So the inverse function is f inverse of x, and that's going to give us the cube root of 2x. Let's rewrite that. Of 2 times x. And what we want is we want the f inverse function of f of x. That's what we want. So we're going to rewrite this function in terms of f of x. So we get 2 times our f of x function, which we said was 1/2 x cubed. So that's what we're going to be solving for. So 2 times 1/2 x cubed, that's going to reduce into just x cubed. 2 times 1/2 is just 1, so we have 1x cubed. And like I said before, cube roots and cubic functions, they're going to cancel each other out, or cubic exponents rather. So cubic roots and cubic exponents cancel each other out the same way squares and square roots do. So we're just left with x. That's exactly what we wanted. That's what we got. Both halves of the composition equation is true. So that means that the inverse that we found is indeed our inverse. And we double checked that and confirmed it with composition. So now all that's left to do is to graph our f of x and our f inverse of x. So we're going to do the same thing we did in the previous video. We're going to make an f of x table. We're going to graph a few points, and then we're going to flip the x's and y's to figure out our inverse function. Okay? So for f of x, or rather before we start picking points, one thing I want to point out is that f of x, when it's a cubic function, is not going to be restricted, right? We don't restrict the domain, so that means we can pick any exponent, any x values that we want. So when it comes to cubic functions, we're going to want to pick x points on both sides of the vertex. All right? So we're picking x values on both sides of the vertex. I'm going to go with -2, 0, and 2, right? The vertex of this cubic function is going to be 0, 0, or the middle point of the function is 0, 0. So I'm going to pick x values on both sides so I can figure out exactly how it's going to look. So I'm going to plug in -2, 0, and 2 into my f of x, either one, they're both the same thing. And when I do, -2 cubed is -8, and -8 times 1/2 is -4. When I plug in 0, 0 times anything is just going to be 0. So that's what I get. And then when I plug in 2, 2 cubed is 8, 8 times 1/2 is 4. So those are 3 points that I have for my f of x function. I'm going to put them into the graph to kind of get a decent idea of what it's going to look like. So I have -2, -4, 0, 0, and 2, 4. So something else to remember is that this is a cubic function. So that means when you get close to the vertex, you're going to cave inwards, then cave back outwards, just like that. That's how a cubic function should look. And now for our f inverse function, like I said, we're just going to take the x and y values that we have on the red table, on the f of x table, and flip them. So now we have -4, -2, 0, 0. If you flip it, still stays 0, 0, and 2, 4 flipped into 4, 2. So we're going to go ahead and plot these points as well. We have -4, -2, 0, 0, and 4, 2. So we're going to go ahead and graph this as well. And remember, an inverse function is just a reflection of f of x over y equals x. And the reason I'm saying that is that your graph, or your inverse function graph, is going to have a very similar shape to your f of x graph. So our cubic root function graph is going to have a very similar shape to the cubic function graph. So what I'm trying to say is you're going to take inwards and outwards as well when it comes to cubic root function as well. So make sure you draw in that curve as best as you can. So your graph should look more or less like this. I'm not very good at drawing graphs, but it should look something like this. So let's go on to number 2. We'll go over one more example. Number 2, we have x cubed minus 9. So first thing we're going to do is we're going to find the inverse. So we're going to write it as y equals x cubed minus 9. You can either switch the x's and y's now and then solve for y, or do that at the end. I'm going to go with how I always do it. I'm going to switch the x's and the y's. So I get x equals y cubed minus 9. I'm going to add 9 to both sides. That gives me y cubed. I'm going to solve for y, so take the cube root of both sides. And I get that y, this goes over here now, equals the cube root of x plus 9. If you decide to do it the way the note said at the previous page, you should get the same thing. It's the same exact process. You're just flipping x's and y's at the very end instead of the beginning, which I like to do. But you'll get the same inverse regardless. Okay, so the inverse what we solve for the inverse is the cube root of x plus 9. But before we can say that this is the actual inverse, we're going to confirm it with composition first. So it's going to be the same exact formula. We have f inverse of x, and that should equal x. And at the same time, we have f inverse of f of x, and that should equal x as well. So for the first one, f of x in terms of the inverse of x, we're going to write f of x first, so we know what f of x looks like. So we have f of x. That's going to be x cubed minus 9. So we have x cubed minus 9. And now we want f inverse of x. So that's going to give us the inverse function, which we found out to be the cube root of x plus 9. We want all of this cubed minus 9. So we replace the x's with what's inside the parentheses, which is the inverse of x. So we're going to solve this out now. So the cubic root and the cubic exponent cancel each other out. So we're left with x plus 9 minus 9, which is just x. That's exactly what we wanted. So that half of the composition is true, but we need both halves of the composition to be true to be able to say that our inverse is indeed our inverse. So we're going to do the same thing on the right side. So f inverse of x. We know that, or we don't know what it is, but what we think it is the cube root of x plus 9. That's what we think it is, and that's what we're trying to confirm. So now what we're going to do is we're going to write f inverse of f of x. And when we do, we switch out the x for f of x, and we get x cubed minus 9, all plus 9. We're going to solve this out now because we need this formula right here to equal x. So we solve it out inside the radical. X cubed minus 9 plus 9 is going to reduce down to just x cubed. Cubic exponents and cubic roots cancel each other out. So we're left with just x. That's exactly what we wanted. Both halves of the composition held true to exactly what we want it to be. So we can say now that the inverse that we found is our inverse. So we confirmed the composition already. We did that down below. All that's left to do now is to graph f of x and the f inverse of x. So for f of x, we're going to make an xy table again. For this point, for this function, I'm going to go with -1, 0, and 1. I think it just worked out the kind of the best, lets you see the shape of the graph the best. So -1, we plug that in. -1 cubed is -1. -1 minus 9 is -10. When you plug in 0, we get -9. And when you plug in 1, you get -8. So we're going to go ahead and plot this out. We have -1, -10, 0, -9, and 1, -8. So we're going to go up. We kind of concave in and back out at that 0, at the vertex. And that's what we get. And now for the inverse of f, we're going to make a table, and we're just going to take the values from the green table, the f of x table, and we're going to flip them. So -1, -10 becomes -10, -1. 0, -9 becomes -9, 0. And 1, -8 becomes -8, 1. We're going to go ahead and plot these points. So we have -10, -1, -9, 0, and -8, 1. So remember, the shape of the inverse function is going to be very similar to the shape of the regular function. It's just going to be mirrored. So our function here will look something like that. I didn't hit the points, but that's more or less what it should look like. I'm just not very good at drawing graphs. So that's what number 2 should be. That's what the graph should look like. That's how you do your composition, and that's what your inverse should be. Okay. Now for number 3 and number 4, I want you guys to pause the video for both of those and work it out on your own. And I'm going to post the answer, and we'll go over it really quickly together. All right. For number 3, this is what you should have gotten. What's in black in the left side. That's how you figure out your inverse. So your inverse you should have gotten should have been f inverse of x equals the cube root of x all over 2. If you did your composition, this right here below the red box is what you should have gotten for the work of your composition. If you got x for both sides, you did your composition right, and your inverse you got is correct, so you're good to go. This is what I got for my graph. Your graph might look very slightly different, and your tables might be different depending on which x values and y values you chose. But the general shape should be like what I have on the graph. There should be an intersection at 0, 0, and it looks like right after 0, 0, and right before it at -0.75 and positive 0.75 as well. So that's more or less what it should look like. And now for number 4, if you haven't done it, pause the video, take a crack at it, and I'll post the answer up in a little bit. All right, for number 4, this is what I got. This is what you should have gotten as well. When we're solving for the inverse, you should have gotten the cube root of x over 6. And then we need to confirm it with composition. Your work for your composition should have looked like this. It's a little neater than the last slide. But this is what you should have gotten. This is what it should have looked like. And you should have gotten it to equal x on both sides, since the inverse that we found is indeed the inverse. And then your graph should look like what I have over here, with only one intersection at that 0, 0. All right, and if you didn't really fully understand something, go back and rewatch me go over number 1 and number 2. Everything is going to be the same exact process, just with different numbers and slightly different equations. But for now, for this video, we're going to keep on going. We're going to go on to page 9, and we're going to go over some word problems where we deal with inverses of a cubic model. So what this says on the top is that in many instances, cubic functions are used to model real-world applications. It is often useful to find and interpret the inverse of a cubic model. As with quadratic real-world applications, it is more useful to write x of y for the inverse of y of x. So before we were solving equations, we always wrote y of x, and we solved it for y inverse of x. what this is saying right here is that sometimes instead of writing y inverse of x, it's useful to just write x of y. Since y of x and x of y are both inverses of each other. To find the inverse, what you're essentially doing is solving the equation for the other variable. So for instance, on number 1 on this example here, we have m equaling this 0.00001 L cubed. If we solve this for L equals, that L equals is going to be the inverse of the M equals. All right, so it doesn't make much sense. Let's go ahead and solve number 1 so you can kind of see a little more what I'm talking about. So for number 1, we're told the function M of L equals that 0.00001 L cubed, and that gives the mass M in kilograms of a red snapper of length L centimeters. So we're going to find the inverse function L of M to find the length L in centimeters of a red snapper that has a mass of M kilograms. And once we do that, we're going to estimate the length of a snapper with mass of 12 kilograms. Or in other words, we're going to find L when M is 12. So the very first thing we're going to do is we're going to find the inverse. So we have M equals 0.00001 L cubed. First we're going to do is we're going to isolate the L. So we're going to get rid of that 0.00001. And to do that, we're going to multiply both sides by 100,000. And that's because we're going to move over the decimal five places. So we need to multiply it by some base 10 that has 5 zeros, or in other words, just 100,000. So we multiply it by 100,000. We get 100,000 M is going to equal L cubed. And then we need to take the cube root of both sides to get rid of that exponent of 3. And when we do, we get that L, I'm going to rewrite this on this side now, equals the cube root of 100,000 M. And so our inverse function is L of M equals the cube root of 100,000 M. And this is what I was saying before. This L function is the inverse of the M function. When you solve an equation for the other variable, that new equation that you solve for is the inverse of the previous equation. So that's what it means to find the inverse. So we figured out what our inverse function is, or in other words, what our length formula is for a red snapper. So we're going to solve for M, right? Or sorry, we solve for L in terms of M. So we're told that we need to figure out the length of a red snapper that has a mass of 12. So L of 12 is going to be the cube root of 100,000 times 12. 100,000 times 12 is going to be 1.2 million. So we have L of 12 equals the cube root of 1,200,000. And to find the cube root of 1.2 million, you're just going to put that into the calculator. We're not going to expect you to actually be able to do that in your head or by working. That's just unreasonable. But when you solve that out, L of 12 is going to be approximately 106.3. So that's what you should have gotten. This is very similar to solving for cubic, sorry, not cubic, but quadratic linear models, not linear models, but quadratic models that we did in the previous video, in the previous day. You're just going to solve for your inverse and then plug in the value that we're given. So we're given 12 in this problem. We're going to plug that in, and we're going to solve for L. So let's go over to number 2. Number 2 is going to be a little more difficult to find the inverse anyway. So we're told the function v of r equals 4/3 pi r cubed, and that gives the volume v of a sphere with radius r. So we need to find the inverse function r of v to find the radius r of a sphere with volume v. So we're going to estimate the radius of the Death Star, which is estimated to have a volume of about 220,781 miles cubed. So very first thing we're always going to do is we're going to solve for our inverse. So we have v of r that equals 4/3 pi r cubed. But we're actually just going to write v of r as just v. So we can actually solve it out. So v equals 4/3 pi r cubed. And now we need to solve for r. So the very first thing I'm going to do is multiply by the reciprocal of 4 over 3. Since 4 over 3 times 3 over 4 is just 1, these cancel out, and I'm left with 3b all over 4 equals pi r cubed. Next, what I need to do is get rid of that pi. To get rid of that pi, I'm going to have to divide by pi, but dividing by pi is the same thing as multiplying by 1 over pi, and the only reason I'm doing that is because it makes solving on the left side a little easier. I don't want to divide 3b over 4 by pi. I'd rather multiply by 1 over pi. It's the exact same thing. It's just that doing it this way it gives you a little less work and makes it look a little nicer. So these pi's cancel out, and I'm left with 3v all over 4 pi equals r cubed. And now I need to isolate that r. I need to get rid of that exponent of 3. So I take the cube root of both sides, and now I'm going to write the r on the left side just to make it look a little nicer. So r, since these cancel out, that's going to give us the cube root of 3v all over 4 pi. But I guess to write it properly, it should be rv. R of v gives you the cube root of 3v all over 4 pi. So that right here is our inverse function. That's how we figure out what our radius is going to be when we're given the volume. So what we're going to do now is we're going to take this inverse function we just solved for, and we're going to plug in this volume. So we want r of 220, 781. So that's going to be the cube root of 3 times that 220, 781 all over 4 times pi. Pi is about 3.14. So when we solve this all out, we get that r is going to give us the cube root. 3 times 220, 781. That is 662, 343. And 4 times pi gives us about 12.56. Yeah, 12.56. So this is all approximate, so I'm actually going to change this equal sign to an approximation sign, and that's because pi is, it never ends, but we're going to approximate it to 3.14. So r is approximately the cube root of 662, 343 divided by 12.56. So we're going to keep on going. 662, 343 divided by 12.56 is approximately 52, 734. And now the cube root of 52, 734 is going to be approximately 37.5. Like I said, we're pretty much approximating a lot of this problem since we can't really write out the whole number of pi and we can't get the exact cube root of such big numbers. We're not going to get a whole number. So we're getting approximately 37.5 for the length of the red snapper when the radius of the Death Star when it has a volume of 220, 781. For number 3, I want you guys to do that on your own, and I'll post the answer in a few seconds. You can double check what you got with what I got. All right, for number 3, this is what you should have gotten. It's very similar to number 2, of solving it out. So the function m of r gives you 44 over 3 pi r cubed, and that gives the mass in grams of a spherical lead ball with a radius of r centimeters. And we need to find the inverse function r of m to find the radius r of a lead lead sphere with a mass m. So when you find out your r of m or your inverse function, this box equation is what you should have gotten. Is r of m equals the cube root of 3m all over 44 pi. And then we need to plug in a mass of 0.37 or m equals 0.37. You plug that into the equation. And then when you solve it out, you're going to get approximately 0.2 for your answer. So that's it for the video, guys, and hopefully it helped.